Okay, I decided to do the video recording or some of the Unit 1 final review. So let's kind of go ahead and take a look at this. So one of the things that you notice with these, right, remember the suffix rule. Okay, so I'm going to start from F. 0 in the front never count, so you know how to count them. You start counting from here. 1, 2, 3, 4, 5. Okay, 0 in the front never count. Start counting from here, but then these are 0. Remember 0 at the end. If there's decimal, you count them. That's 3. Okay, same idea. Decimal at the end, so you go ahead and count these. That's 4. Okay, no decimal, don't count them. This is only 3. Okay, I'm not gonna do the rest. Well, if you want the rest, I will take another video of that at the end, answer key. All right, calculation, dividing versus adding and subtracting. There is 2 different suffix rule. When you're adding and subtracting, you're just chopping things off, right? So for example, this one, 4.86 minus 1.332. When you're subtracting, right, I mean, you can do calculator or you can do without it, right? Let's just say we're doing without it. This is 8, this is 2, this is 5, right? Am I doing correctly? Okay, and then this is 3. Now, what you're gonna do now is you're gonna chop off with the least number digit, 2 decimal places. So you'll see that this is where it is, and then you're gonna round this up. So then therefore this become 3.53. The reason you round it up is because the next number is 5 or above, so you round it up. Okay, let's do dividing. So dividing and multiplying. Let's say I'm doing multiplying. 0.062 times 1.004. You know that is still approximately the same number, right? I just divide it, you get this number. Notice that this is still the same answer. The reason is because this has 2 suffix, this one have 4 suffix. My answer can only have 2 suffix. Okay, I can do another multiplication one. Let's say this one, 132.009 times 0.0050. So you're gonna get about 0.66. I'm gonna say, is it done? Yes, because this is 2 suffix. This one has way too many suffix. My answer is only to 2 suffix, right? Okay. Scientific notation. If there's decimal, start from decimal, move until you have 1 number in front of decimal. 1, 2, 3. I have 1 number. We're done. 2.30 times 10 to the, remember this is less than 1, so this is negative. How much you move? 3. This one don't have decimal. I'm gonna start from here. 1, 2, 3, 4, 5, 6, 7, 8. I'm gonna stop because I have 1 number in the front now. Okay, I'm afraid I'm gonna forget it, so I'm gonna write it down how much I move. I move 8 spaces, and I'm gonna write down 1.0204. Okay, easy, right? Dimensional analysis. Okay, I'm gonna do this one. This one is the one that most people get into trouble. Millimeter to liter. Millimeter cube, right? So 1 cm cube is 1 milliliter. You can use this one. 50063.5 mm cube. Now, 1 0 millimeter, 10 millimeter is 1 centimeter. Okay, but you want to cube it, you cube this whole thing. Now, that's not going to be 10. That is now becoming 1,000 millimeter cube, which is happen to be the same thing as the liter. 1 cm cube is 1 milliliter. 1,000 millimeter is 1 liter. Okay, so how we're gonna do cm cube, milliliter, milliliter, millimeter cube, millimeter cube. So when you're doing, you're dividing and then dividing again. Okay, because it's on the bottom. So we're gonna get 0.0500635 liter. Okay, easy. Alrighty, let's go do this. We're just gonna set these up for you guys. Okay, this one. Find natural isotope 70. Okay, by the way, when they say U, these are the mass. Okay, these are my mass of the 5 different things. You have a graph, percentage, perfect. That means I can just convert these into percentage and just multiply simply. So I can kind of like draw the line through it so that I can tell where they are at. Right, that's 20. That's a little bit less than 30. That's not 40, which makes sense because 20, 10, 10, that's a 40 plus 40, that's 80, and then that's not going to be 30. So this is a little bit less. Right, so it's not exactly. 70% is going to write as 0.70 time the molar mass, 69 point. Remember, I'm looking at 70. Oh, not 70%, that's 20%, so 0.20, sorry. Okay, time the germanium 70 mass, which is 69.9243, plus, I want to do another percentage. This one, this is, I would say 27%. Yeah, about, right? So I want to say 0.27 times the mass of the 71. Right, no, 72, yeah, 71.9217 plus, not done yet, you're gonna have 5 of these. Okay, this one is about 10ish, maybe 9, so 0.09 times 72.9234 plus this one is about 40ish, but not really, 37 maybe, time 73.9219, and then plus this last one is about that, a little bit less, maybe 0.08 or so, and then 75.9214. Okay, all those, I don't think that is 100%, so you might want to make it 100%. Okay, hold on a second. Yeah, I'm a little bit over. So I would say like this is like 0.07 or something. About the same thing as that one. It's a little bit less. Yeah. Again, we're guessing. So if you add up these percentage, that's what I was doing earlier, you should get 1. Right? Because it's percentage. You just multiply and add, you should get your answer. Since they give you unit in U, I'm going to write in U as an answer. Okay. Now let's take a look at this one. Oh, this is an interesting question. We're looking at boron. I mean, not boron, bromine, right? If you keep reading it, we're looking for bromine. Okay. And then it said iron typically carry a charge of +1 for major radial fragment, right? And then you are seeing these fragments, and you said y is at the 60 is about twice as high as 158 or 162. Well, take a look at the peak here. A little bit less than 80, a little bit more than 80, right? 79 and 81, about the same length. That means bromine in natural is either BR79 and then BR81. They're about 50-50, okay, approximately. Like maybe 50% abundant. Okay, about 50 also % abundant. Now take a look at here. Why do you think they're doing this? They are here because they are BR2. Now let's try to think about the mass. BR2. BR2 can be BR79, 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 BR81, and then BR81, BR81, which means this give about 162 mass, 158 mass, 158 mass, and 160 mass, right? 160 mass is twice as much. That's because when the BR is equally abandoned, right, and then when they are pairing like this, they're gonna have more BR79 and BRB81 left to pair each other than to pair like this. Okay.